Right, a periodic waveform f of t is defined as follows. F of t equals t minus 1, t greater than minus 1, and less than or equal to plus 1. And then they're telling us that f of t plus 2 equals f of t. Well, that line there otherwise means that the period big T equals 2. Because whatever happens, the same thing happens 2 units further on, or 2 units behind. So sketch the waveform on this domain. So roughly, that's very roughly looking there. I'm going to do that again. Right, that's vertical, that's horizontal. So that's f of t, it's like the y-axis, and this is our t-axis. And 1, 2, 3, minus 1, minus 2, minus 3. 1, 2, 3. We could go the same on the y or the vertical axis. 1, 2, and 3. Now we're focusing on this guy here, right? T less than or equal to 1. So when t is equal to 1, f of 1 equals 1 minus 1 equals 0. So when t is 1, f of t, the height is going to be 0. And it's less than or equal to, so it's going to be a solid dot there. And then looking at the other end of this condition here, minus 1, f of minus 1 is equal to minus 1 minus 1. And that's equal to minus 2. But this time it's less than, it's not less than or equal to, so it's going to be a hollow dot. So with minus 1 here for t, that will produce an f of t value of minus 2. So it's a hollow dot down here. And we can join them now by a straight line. Like that. Now, we need to draw this between minus 3 and plus 3. Now you see this, the period is t, is 2. T equals 2, big T equals 2. So 2 hops further on, we'll have the exact same pattern here. 2 hops further on, 1 hop gets us to 0 on our x-axis, and then we get to 1 here. We have a hollow dot here. We join them by a straight line. Same here, 2 hops further back, 1, 2, we have a solid dot here. 2 hops further back from this hollow dot, we have a hollow dot underneath our minus 3 here. And the final bit, 2 hops back from this solid dot, we'll have another solid dot here. So that's sketching the waveform between minus 3 and plus 3. Is it an even function? It's not going to be an even function. Why? No, not even, because it is not symmetrical about the y-axis, about the y or vertical axis, because it's not the same on both sides. If you were to fold the page down along the f of t or y-axis and fold it over, it wouldn't be the same. You know, if it was something like this, it'd have to be, see where we have this minus 1 guy, this guy here. In order for it to be symmetrical, you have to have the same thing over on this side like that. So that you'd be folding along this line here, and it'd be the exact same. But if you fold this, it won't fold over on itself properly. So it's not even. And also the mathematical version would be f of t would have to be equal to f of minus t for it to be even. And you can see that well, we won't go there actually, because the graphical one is the one to go with here, right? I'm going to pause that now, hopefully.